Participants of the conference, we present to your attention the results of the study, which, through the prism of the theory of sustainable development, considers and specifies approaches to determining the optimal and harmonious ratio of operating and investment costs in the grain industry. Ensuring the sustainability of agricultural production and the implementation of its social and economic functions determines the increase in grain production, which places strict requirements on the fleet of combine harvesters, the quantity and quality of which is constantly deteriorating. The problem can be solved by increasing investment in its renovation, and the complexity of forecasting the development of economic processes under martial law necessitates the search for approaches to determining the optimal level of investment and harmonizing it with the level of current costs. The first step towards solving this problem was to determine the equation of wheat yield dependence on variable costs per hectare of harvested area, Formula 1. Subsequently, the two were combined into a system that allows determining the expected yield if the harvesting campaign ends within the optimal agronomic timeframe or if it is extended beyond 10 days, Formula 3. At the same time, the value of the variable D was calculated based on the recommendations for its definition given in studies on the organization of grain harvesting, Formula 4. Taking into account the purely individual nature of the formation of the size of wheat acreage and the fleet of combine harvesters for each agricultural enterprise, their ratio in Formula 4 was replaced by the planned area of wheat threshing with one combine harvester, Formula 5. After that, based on the analysis of statistical reports, it was determined that domestic grain producers are mainly equipped with units with an engine power of 330 to 335 horsepower. With this in mind, a John Deere S670 combine harvester was chosen as the base model. Substituting the actual and recommended values of the hourly productivity of this combine, shift duration, and working time utilization rate into Formula 5, a function was formed to determine the dependence of the duration of the harvesting campaign on the planned threshing area with 1 unit and variable costs per unit of crops, Formula 6. Subsequently, the variable D in the second equation of the system, Formula 3, was replaced by the right-hand side of Formula 6, which allowed us to obtain a model that allows us to determine the harmonized values of investment and operating costs that maximize yield at a fixed value of the planned annual load on the unit, Formula 7. A graphical illustration of the dependence of wheat yield on variable costs at different harvesting areas shows a reduction in unproductive losses when the load on the combine harvester is reduced and the technological efficiency of grain production increases. Figure 1. The next step was to model the impact on the economic efficiency of grain production of the intensity and load on grain harvesting machinery. To determine the expected volume of marketable product, the right-hand side of equation 7 was multiplied by the selling price of wheat grain by agricultural enterprises in Ukraine in 2020, 386 hryvnias and 75 kopecks. In doing so, we assumed that the grain production in equation 100% marketable. Later, to determine the expected profit, the same part of the equation was reduced by the value of variable costs X and the average fixed cost of wheat production, 2,711 hryvnias, Formula 8. A graphical interpretation of behavior, Figure 2, shows a decrease in the maximum profit and the optimal cost that guarantees its achievement in the event of an excessive increase in the load on the combine harvester. For example, if each combine harvester of an agricultural enterprise has 300 hectares of wheat crops, the maximum profit of 4,200 hryvnias per hectare is guaranteed by a technology with variable costs of about 9,000 hryvnias per hectare. In contrast, the choice of this technology with a load of 1,200 hectares leads to a loss of 2,700 hryvnias per hectare. Under such a load, the optimal technology is one with variable production costs of 3,900 hryvnias per hectare, which will result in a financial result of 400 hryvnias per hectare. Thus, if each combine harvester threshes 1,200 hectares, It would be more appropriate for the farm to use a technology with variable costs per unit of crops almost 6 times lower than the technology that allows for maximum yield. Subsequently, the increase in depreciation charges, Formula 9, and other fixed costs, Formula 10, caused by capital investments was included in Formula 8. Thus, taking into account the potential increase in fixed costs, the system of equations for determining the expected profit has a new form, Formula 11. The graphical interpretation of the behavior of function 11 indicates the nonlinearity of changes in the return on investment, figure 3. In particular, a reduction in the workload from 1,200 hectares to 900 hectares, with an increase in the expansion of the harvesting machinery fleet, causes an increase in fixed costs by 300 hryvnias per hectare. As a result, it becomes possible to switch to a technology with variable costs of 5,000 hryvnias with a simultaneous increase in production intensity by 1,100 hryvnias per hectare, table. At the same time, the reduction in the duration of the harvesting campaign and the reduction in unproductive costs resulted in an increase in yields of up to 23 centners, which, with 100% marketability, is equivalent to an increase in revenue of 1,900 hryvnias per hectare. As a result, the profit of the agricultural enterprise increases by 400 hryvnias per hectare. Similarly, if the workload is reduced from 1,200 to 600 hectares, the expected increase in profit will reach 1,000 per hectare. At the same time, if the load is reduced from 1,200 to 300 hectares, the financial result will increase by only 900 hryvnias per hectare, which indicates a decrease in the marginal cost efficiency. For example, if the fleet is expanded to reduce the workload from 900 to 600 hectares, the increase in fixed costs is 700 hryvnias per hectare. The optimal level of variable costs is 1,700 hryvnias per hectare, and the marketable output is 2,900 hryvnias per hectare. As a result, the marginal profitability of costs will be 20.8%. On the other hand, if the load is reduced from 600 to 300 hectares, fixed and variable costs and marketable output increase by 2,300, 1,900 and 2,900 hryvnias per hectare, respectively, and the marginal cost unprofitability is minus 30 whole and 0.9%. The tested methodological approach allows determining the optimal level of investment in the renovation of the fleet of combine harvesters, taking into account the peculiarities of wheat production, grain price conditions, material resources, harvesting equipment, and financial factors. The calculations showed that it would be economically inexpedient to invest in the renewal of the combine harvester fleet with John Deere S670. Combine harvesters are similar if one unit accounts for less than 600 hectares of wheat crops. A positive feature of the tested approach is the ability to minimize unproductive costs by taking into account technological and market factors in determining the optimal level of cost. Instead, the introduction of innovations leads to a change in the form of the production function, which should affect the dynamics of the marginal efficiency of investments, and therefore it is promising to expand the approaches to modeling and take into account the role of innovations in finding the optimal level of current costs and investments. Thank you.